All right, day 6. So I'm pretty late for this one. It is 9 o'clock and I just got home, but I've been looking forward to this one all day. Right, so the ferry quickly brings you across the island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races, open to the public. Grand prize is an all-expenses-paid trip to Desert Island. I wonder where we're going. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. Okay. You manage to sign up for the competition. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can. And you win if your boat goes further. So it's kind of like an FE race, a Formula E, where you have 45 minutes to do the most laps possible. And tiebreakers are whoever's furthest, so it's distance based. As a part of signing up, you get a sheet of paper that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther than in each race than the current record holder. The organizer brings you over to the area where the boat race is held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. So they're toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows it to move. Okay, on, stop, charging, release. Okay. Boats move faster if their button was held longer, but time spent holding the button counts. You only hold the button at the start of the race. Okay. Alright, I see. For example, time 7:15:30, distance 9:40 300. This document describes 3 races. Yep. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. Yeah. Your toy boat, oh my god, again, huge puzzle input. Your toy boat has a starting speed of 0. Yeah. For each whole millisecond you spend at the beginning of the race holding the button down, the boat's speed increases by 1 millimeter per millisecond. So, okay. So, it's like acceleration. No, it's not. Well, yeah, it's flat acceleration of 1. Cool. So because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all. That is, holding it for 0 milliseconds. At the start of the race, the boat won't move. Hold it for 1. The boat will be at 1. Okay. So, okay, fine. Since the current record for this race is 9 millimeters, there are actually 4 different ways to win. Yeah. Wait, it's 9 millimeters? Wait, isn't this one the fastest though? You hold the button for 2. You will get 5 milliseconds to move. Alright. In the second race, you could hold the button for at least 4. The third, okay. You see how much margin of error you have. Determine the number of ways you can beat the record in each race. You simply multiply these values together. So, alright, that's really not bad. Cool. Let's face the example. And let's do, we need standard, don't we? We need to say time time tokens equals standard.mem.tokenize sequence. So we want U8, we want to tokenize input 0 and on spaces. We want to do times tokens.next and throw that into the void. there always three? Three races? Or four? 3 or 4. So I guess I'm just going to make an array of 4. Yep. Var allocator equals standard dot age allocator. Well, actually, no. Don't really know what the differences between the two would be. So we should get 7, 15, 30. So var times equals. I'm actually going to do const. No. Yeah. So equals allocator dot alloc, and the type that we want is a u32, and we want 4 times and distances. Same thing. And I think we do it. We need try as well because alloc can throw an error. So then, just what we do for now while time tokens dot next token times, oh, and then we can have another one here. Index times that index is equal to try standard.fmt.pass int of the token. Now the u32 token and base 10. Distances index try. Ooh, can we do? Special brackets. Can I not have? But a 4 would work. I'm not sure if this works. And now we can do distances.next as well. So we can have time, distance, index, time, distance. And if you do compile. Not distances, I mean distance tokens. Replace that. Distance tokens. Not assignable to a range. Alright, never mind. I think I was trying to be clever there, but I guess not. We can't do that. It's strange, we can't have like multiple statements there. I guess our index u size equals 0 for 1. But what we can do is we can do distance is var distance is equal to distances distance tokens dot next question mark goes in there. Const print equals standard.debug dot print any, and we're going to print times distances. Another character. So if we're doing tokenized sequence of spaces, oh, and we're not throwing that distances away. Distance tokens away. No more runtime errors. But we do get this. What I do want to do is I want to try something. If times 4 is equal to standard.num, I wanted to see, like, you know, Is there like a max? Mem.max? No, so I guess times 4 equals, just going to do 0 there. And if it is 4 by the end, that means we're on example inputs. So what we're going to do is we're going to do times dot, oh, how do I, allocator dot resize, resize old memory times to be size 3, distances size 3. I wonder if that works, and we definitely need to do try. What do you do? Request to modify the size. It is guaranteed to not move the pointer. However, the allocation implementation may refuse to resize, returning false. Oh, and we need to throw those into the void. Zero, 1, 2, 3. Oh, whoops. Yep. Oh, it didn't resize. That's annoying. You know what I'm gonna do? Just because I'm really planning about this. Times copy equals try allocator alloc u32 3 distance copy. I'm gonna say times copy 0 is equal to stand.mem.copy. Ooh. Oh, we can't copy because they're different. I just want the length to be perfect, basically. Distance copy. Distances. And what we're going to do is we're going to say times is equal to times copy, distances is equal to distance copy, allocator dot free distances. Well, I guess we would have to do it here, because then it would be like kind of a null pointer. Let's see if the zig like this. Hello. Zig doesn't mind us. Alright, a lot of nothing, basically. Ignore that, doesn't matter. What's that about semicolon? Oh. Okay, cool. We have times, we have distance, the right size now. Now let's actually solve the problem. So time is 7, and that's 15, and this is 30. It's sort of like an equation, right? Like we can probably have an optimum somewhere. Like you start at 0, 0, and it goes up and then back down. Like a quadratic. Yeah. 0. So like this is what I'm thinking. If you have like minus x squared plus 2x, you see the roots. And then this here is the optimal point. We would have to round, right? We would have to round, but that's okay. Right, would that work? Let's think about their example here. So we have a distance of 7, because you can start by holding you can start by holding the button like nothing, therefore you go nothing forward. But I think this is too high. Like it's seeing the quadratic seems too big in general. So for each whole millisecond you spend at the beginning, so like the gradient, it would have to come up. Where does this one go, for example? Yeah, so 0 and 0. You hold it for 1, you get 1. You know, 6 even. So oh god, Excalibur. I want to write some stuff. I want to do some math. This feels like an interesting problem. So if you have a quadratic that looks like that, well actually that's the origin, and then this here is 7, 0, where the x-axis is time spent holding button, and this here is distance. We know that if you hold it for 1 millisecond, the distance is going to be 6. So we also know that it comes 1 here, goes over to 6, so 1, 6. So the way to solve that is that you have two roots, and you know that this holds here. So you have x minus 7 is 0, so then x squared 7x, but then this doesn't fully scale, so what you need is a big K on the outside to make it work. K, 7K. So then if that is equal to 6, and when x is 1, we have K minus 7K equals 6, minus 6K equals 6K is minus 1. Oh, wait. Is that right? That's... yeah, I don't see why that's wrong. So then what, the quadratic is just x squared plus 7x. But then... what? But then it comes down like this. Excuse me, what? Or maybe let's just take a more general form of the quadratic. We know that ax squared plus bx plus c equals 0. I mean, we can then, so minus square root b squared minus 4ac over 2a. That just like, well, it's completely overkill. Oh wait, no. We know c is not a thing, right? Because it always crosses 0, 0, so it's 0. So ax squared plus bx equals 0. Then we can start to do our thing. So when x is equal to 1, y is equal to 6. So a plus b equals 6, and let's find another point. Another point which is like the opposite, right? Because quadratics are symmetric, so 6 and 6 again. So 36a, so 6 squared plus 6b equals 6. And then we solve these. I don't really have a calculator to hand, I suppose. We minus, one of them's going to be 0. Oh, what? Come on. Is it? No, they're just ratios of each other there. Minus 5b equals 0. 35a equals 5b. So, 7a equals b. So it's actually going to be ax squared plus 7 equals, yeah, 0. A 7ax. So it's a multiple here. But that's kind of that's just what I started with. But I haven't found out what a is. Oh, when x is 1, this gives me 6. So a plus 7a is equal to 6. 8a is equal to 6. A equals 6 over 8. So is this 3/4 x squared plus 21 over 4x equals y. That's my equation for that first one. If we plot that on Desmos, I felt like a really backwards way of finding it, right? So maybe I'm just misremembering my maths lessons from school. So okay, comes in like this. Oh, and then it hits the values on the outside. Right, I understand. Oh, but then we're doing something wrong. Maybe we just code. No. See, I don't want to just code. Maybe I pick a different point. Maybe I pick the 2. The 2 gives me 10. 2 gives me 10. So then we had a plus b equals 6. And then x squared 4. A plus 2b equals 10. Let's do some backwards taking away. So 3a plus b equals 4. Oh wait, no, we need to times that top one by 2, so it's actually going to be minus 2a minus, 2a plus 2b equals 12, which is 2a equals 2. A is 1. So if a is 1, b is 5. So yeah, now we get different answers. A is 1. So x squared plus 5x The fact that they are positive is stressing me out like a lot. Yeah, for sure. Like, yeah, maybe I'm doing something wrong. Oh, clearly. But they definitely have to. It definitely has to be a negative quadratic, and it definitely has to be this one, plus 7x. And let's times the whole thing by k. because we want, like, we want 1. Oh wait, 1 already matches up with 6. 6 matches up with 6. I am stupid. That just works. But it doesn't have to work. It just does in this case. Right, we could have to shrink it a fair bit. And it's just in this case we don't. So the question was, since the current record for this race is 9 millimeters, there are currently 4 different ways you could win. You could hold the button. Yeah, so in a second race you could hold. So there are currently 4 different ways you can win: 2, 3, 4, and 5. So if we look on decimals, 2 comes up there. Yeah, so basically anything above 9. 1, 2, 3, 4. Cool. Just to test the stuff out. Then we need to look at that second one. Just time 15. So this needs to be 15. So it crosses 15 there. I think this one is probably a little bit weird now. Like, okay, 1 goes to 14. Is that right? 1 goes to 14. Oh, but we didn't factor in. Oh, distance is record, right? Yeah, this is the record. In the second race, you could hold the button for 4 millimeters and at most 11 millimeters, a total of 8 different ways. So the record was 40. So no, I think this is correct. It's just like looks like a lot. So 40. So there is 1, 2 integers above 40. You could hold the button for at least 4. That's most 11. Yeah, that's not right. Because if you hold the button down for 1, you'll travel 14. And 1 does not equate 14 here, does it? No, it does. Oh yeah, there's many more integers in the middle. I think that's it. You just make it quadratic. And then you just ask yourselves which ones are above. And just to be extra overkill, like if we have if we do have the quadratic like minus x squared, minus there, or maybe that's what I was getting on, minus plus 7x. Right, if we have this and we ask like, what was it? For which values are you more than 9? Minus x squared plus 7x minus 9 is bigger than 0. And we factorize this to be something, and we take the values in between. Is this all maths? Let's yeah, fuck it. This looks like all maths. Why not? Let's do it. You know, this is giving some real OP vibes. Quadratic equals struct, which has A being FA2, and you know, just to make things very easy, I'm just going to change any U32s to be I32s. Just U I32. There's no C in this quadratic. Oh no, that could be, because we could make one. And we're going to have a pub func solve that takes in self of quadratic, and it's going to return two values, right? A struct of, actually I'm going to do it up here, quadratic solution is a struct of x1. You can be a float. Should we make the whole thing floats? I think we do. I32s, you are now F64s. I32s, F64s. And what we're going to have here, we're going to return a quadratic solution. So you're going to say, two solutions, right? Of course. Now x1 square 1 is equal to minus self dot can I? Alright, self dot b x underscore 1 equals self dot minus self dot b plus standard dot math dot square root. I feel like we're going to do that a lot, so math equals standard dot math. Of b squared, so math dot pow self dot b by 2 minus 4 self dot a times self dot times self dot c, and the whole thing divided by 2 lots of self dot a with some brackets because I, precedence and stuff. So now this is going to be the minus version of that, and we're going to return a quadratic solution with x1 being x underscore 1 and 2, 2. Isn't that it? I feel like that's it. Isn't that exactly how we did these? Oh, we have to do a dot. Great. And basically what we're going to do is we're going to do for 0 dot dot times dot length the index. We're going to make a quadratic based on this. So var quad equals quadratic with dot a being times at I. Oh, it's going to be, no, it's going to be -1 every time. And dot b is going to be plus positive whatever times at there is. Okay, and then c equals 0. And no, c not 0, c distances at I minus, because we're going to attempt to solve that. We're going to do debug print any dot slash quad dot solve. Right. Okay. Math.pow. Yeah. Time. F64. F64. Math.pow must be an integer. X to the Y. Reach the reachable code. Ah, what's going on here? Oh, I don't quite understand that. Must pass an integer. Let's have a look. Zig learn maths. Pow. You know what? Let's just you know, self times self.b. No, just no point doing that. Let's not worry. Oh, still unreachable. Oh, that's interesting. Returns the square root of x. Side of all the slotted should implement directly in square root built-in function. What? Let's Google this. Zig square root. Oh god, that's a lot of code. For all floating point types. Is it like if I do add square root? Square root. Okay. I don't really understand, but no, that's still just being weird. Is it because, am I giving it like a negative number and it's like it doesn't like the, does not like the imaginary realm? Oh yeah. Well, what? In here? I'm so confused. Can I not multiply floating points together? Is that what's happening? If I go like print, if I go like var x, you're a floating point. You're 4. Any x times y. And like, I never call this or this. Really? Do I have to add an F or something? What? Why is it, we can't multiply floats? Floats. Floats. I'm just confused. They can't multiply floats? Question mark? Right, so maybe this stuff isn't quite there. So we have to do like math.mul xy. Right, maybe the times operator doesn't quite work. Oh. Expected vector of integers. Oh god, what now, man? Do I have to try this? Do try or something? That's such a strange error. Yeah. Okay, well, maybe we keep these at u32s, right? And so I don't really want to spend that much time trying to fix this. These should be u32s, I guess. u32s, and we can try and solve it, but the solution returns that. Yep. Take the square root. Math.square root. Oh, let's say about discriminant, which is a flow 64. And we can do as f64. We can kind of omit this, take that, and we can discriminant here. I wonder if you work. You don't work. Oh, I32 is right. Replace with I. Yep. I. What about that siglen? We had floats here. Float from int. I think this works. Converts an integer to the closest floating point representation. And maybe we don't even need the as after that. Must have a known return value. Oh, right. So F64 straight away. Okay, we learned something. Ooh, and float b f64 equals float from int self.b. And we also do float a self.a, and we do here float b, and on the end float a. We are compiling. We have compiled. We have solutions. That's great. Great. We want to solve, and we want to round So like if the solution comes in like just before an integer, we still have to go to the next one. So it has to be math dot well, solution equals that, and we have to do math dot seal start, like that's going to be like our range, the start of our range, and x2 print range, like from when can we start and when can we end to actually get the results, like how many times can you win. Okay, 2 and 6 for the first one, right? 2 to 6, 6 not inclusive, I guess, and 4 to 12 for that second one. So 4 to 12, but we take away 1, and then 11, 18, 11, 20, yeah. Nice, nice. Okay. 4, 8, 9. So awesome. That's really cool part 1. I guess we are gonna keep you at float to int from float. Yeah, let's keep you. Now let's take them and be int from float. I need to learn more about these ats. I don't quite understand what they are. So if I go to definition, I can't. I think they must be compiler functions or stuff that goes into directly into the runtime. Something like that. I'm not sure really. What is this? Oh, eth2 equals 0. What? Int from float. Oh, you don't expect this, but you do expect you to be typed. And what we're going to do is we're going to do part 1 plus or equal to start to end minus 1 minus start. And part 1. Cool. So that took a little while, but I really wanted to figure out if it was quadratics and not going on like a massive tangent. Where am I printing? Up here. No, I don't care. Oh, and it is times, and therefore you have to be 1. And then save. 189. That's not correct. Let's print some stuff, which is going to be end minus 1 minus start. So 3 different ways. Oh, okay, right. I see why we don't do the one there. Do 320. Also doesn't seem right. Well, isn't right. 4, 8, and 10. Oh wait, 4 is not right. That's definitely not right. Let's print start and what have we done wrong? We've done math.seal on both solutions, and we've done int from float. Start 200. So for that first one, there are 4 different ways to win, and we get 4. For that second one, we get 8. For that last one, we get 20. Oh wait, we must have to seal one and floor the other. I think the one on the right side of the quadratic has to be floored. No. Is it the other way around? No, that can't be. Oh, okay. This is posed like a really weird, interesting question. Like if we have this quadratic and we want to find out the ones above 40, like integers above 40. Right there's 3.4. The starting one would be the ceiling. And then after it is the floor, right? Yeah, it's the one further back. So it is ceil and then floor. So now it goes 2 to 5. 7 and 10. So this last one got 10 and 20. At least 11. Are we taking away the right distances? That's really weird. It's probably just me being silly. But I wonder if it is like something to do with our solutions. So for that second one, which is 40, we got 3.46 to be over 40. 3.46, and we got 11 point something. 11.53. 11.53. So then we floor that, so it goes down to 11, which is like there. Yeah, so if we floor that, we get 11. Oh, but it is if it's like an answer, like straight away like that, then we have to treat it differently, because this is non-inclusive. Yeah, so if it's like, right, this is kind of annoying. Yeah, we have to go and say if we can keep the star, but if end, if solution.x to mod oh, we want to check if it has decimals. So basically divide by, if it doesn't have decimals. Oh, wait. How do we check the number has decimals on it? Check float has decimals. Just full stop. Check whether a float number contains decimals or not. Oh, mod 1. Yeah, I was thinking that, but I was like, oh, that doesn't make sense. Is equal to 0. Then actually the end is equal minus or equal 1. Whereas otherwise we add 1. This might be really weird. At rem or at mod. Okay, at mod this 1. Okay. Part 1 of 288. 288, so I think we're on to a winner there. And I know this coach could have been brute force, but come on, it's just so much cooler to do stuff like this. And this might be wrong, but it's not. Let's go. Quadratics, and hopefully we've set ourselves up for greatness for part 2 here. As the race is about to start, you realise the piece of paper with the race times you got earlier actually was just very bad kerning. Oh, right. There's really only one race. Ignore the spaces between them. So, for example, 4 now instead means this. Now you have to figure out how many ways there are to win. Oh, this should be so easy. Basically, we're going to copy that part 2. And wait, does he want us to? Now you have to figure out how many times. In the first example, 7 in the record you need is, yeah, so what we're going to do is we're going to say, we're going to take all the numbers. Yeah. Let's start with, we're going to say var time, which is a u32 starting at 0, and distance. Do we get u size here? Let's use u size because just thinking that you're going to run into some overflows with those last ones. Time u size is equal to for 0 dot dot times dot length. You're going to do time is equal to, it's plus or equal to times at I times 10 times I so 10 or 1, but if I is 0, then actually we want to say time plus or equal to times of I, continue, otherwise we do want to do that, and we want to do the same for distances, and I'm going to get type errors, I know, distance. The reason I'm going to get type errors is test, because we're mixing u size and u32s, so rightfully we should get some type errors there. Time distance, and we're doing that here as u size, and same here as u size, as u size, as u size, how do we do that? At int cost. Test u size equals at int cost. Converts an int to another int while keeping the same numerical value. The return type is inferred result type. Ooh, zig i32 to u size. I wonder if there's a way that we could potentially do that, or if this at int cost is actually safe. Times I. Let's do here. Current time. Current time. Current time. Current time. Okay. So I don't think that was right. Oh yeah, that wasn't right because we're not like joining the two. Oh yeah, that's silly. We shouldn't do this like this. I'm stupid. We're like right up here. We should like take, whilst they do have a next. Can we do var string time equals try allocator dot alloc const u8 or just u8, array of u8 of size like 100, string distance, same thing. Let's just defer allocator dot free string time, string distance, we do this, oh yeah, we're passing the end of time there, but actually for 0 dot time dot length I, actually var I usize is 0, do underscore there, so actually string time at I equals time I, and I equals 0, distance dot length, oh wait, no, var j usize 0, distance string distances is equal to distance at j plus or equal 1. I j all right, let's change it to k then. Do you work? Bunch of u8s, not that. All right, time. If it goes to time dot length, oh, we have to do the plussing after. Come on, man. We do it for time dot length. It goes 0. Oh, because we need it. We actually need k underscore k. We got to do underscore k here. Underscore k. Actually, we go underscore k. So much for copying some strings, man. Print nums dot slash string time, string distance, and these can be just any. I mean, I guess that's kind of right. That's like kind of correct, and then k and j are the thing. So what we could do is we could say part2 time, which is equal to try standard dot par dot fmt dot pass int u32. There's going to be string time from 0 dot 2 k base 10. Part 2 distance, string distance, and here we're going to do part 2 time, part 2 distance. Do you compile? 2, 15, 30, 9, 40, 9, 40, 20. That's not right. It missed out 1 on the end. Do you see? Did the first one fine, but it missed out that one on the end. Because it's not K, it's J. Perfect. So now, all we have to do is make a quadratic. We have to solve it, we take the start, we do this, and then we set part 2. Part 2. What does it actually want? So part 2. Print 2. A is minus 1, and this is gonna be part 2 time. C is gonna be the negative of part 2 distance. I wonder if these have to be I32s. Yeah, they do. Type errors anywhere. What's going on? Integer overflow with the discriminant. Really? I128. I128. Like, no integer overflows here. You know, F128 as well. Alright, anywhere there is an F64, there's going to be an F128. The same thing for I32, there's going to be an I128. Wow. Just very, very overkill. But did it work? 7156. No. Oh yeah, 7156. And oh, yeah, I think that's right. 138, that was part 138. Oh, that was a beautiful day. Very nice day. Yeah, that was just so nice. I've never seen an advent of code problem that required like quadratics. Like, yeah, it's probably the real world use for them. Never actually had to use my math knowledge outside of teaching or learning maths tests, but that's really cool. That's love that problem. All right, that was a nice one. I learned quite a bit about Zig's just handling of floats in general, to be honest. How you would do this and the considerations you need in a language like this, because you can't just time stuff, especially floating point stuff doesn't work like that, because there's no operator overload. The times is literally a times, right? It would be translated to a literal mult instruction in x86 assembly, I imagine, at least. So you need to have more caution when doing that type of stuff. Awesome. Yeah, thank you for watching, and see you tomorrow.